Howdy and welcome back. So one of the, topics I was looking forward to introducing is this idea of, okay, so maybe we're reading some contents from a file, right? And we'd like to store those contents in, say, an array. Maybe they're integer values and we'd like to store them in an array of integer objects. Let's say that we don't know how many objects we're going to read, but we do have access to the free store. So maybe we create an array with some sort of initial capacity. Okay, well, what happens when we actually read that many objects? Is there a way that we could expand or resize a dynamically allocated array? And we'll see here, there is a way to resize it, but it's not like we're stretching it in memory. We'll see here that it's kind of a multi-step process, and in terms the creation of a new array and copying contents over into this new array and deleting the old. So let's go ahead and look into this. I want to kind of encapsulate everything that we're going to be looking at with this within this problem in a struct called myArray. And I'll go ahead and define what its data members are here. Array is going to be a pointer to an integer object. The object to which it points to is going to be a dynamically allocated array. Capacity is going to be the number of objects that we can store in that array. Okay, so that's going to be how many we can actually store. Size is going to be the number of objects within that array. So if we start out with a capacity of 5 and we haven't added anything into that array, size is going to reflect 0. The second we add the first element at index 0 to our array of 10 elements, size will increase by 1. When we add, say, an additional element to array of 1, so its first index, size would increase to 2. And we could continue adding to this array with size essentially communicating the current position or index that is open that we can actually add to. And we can continue adding at that index, and each time we perform an add, we'll increase the size by 1 to acknowledge that, okay, the next empty location is at whatever. For instance, if we have an array of 1 element, that element is going to reside at index 0. Size would reflect 1 because of the 0 indexing, but size is also going to tell us the position that's available. And then when size meets capacity, well, we've used up all the slots there and we'll have to perform that resize operation. So with all of this kind of in mind, let's define a function read data from file. And the question is, how would we resize the data objects array when we run out of space? So let's go ahead and assume we're passed in a file name. We're going to bind that file to an input file stream IFS. We'll go ahead and initialize our data object. Array will point to, on the free store, essentially a array of 2 elements. The capacity will be 2 and the size will be 0. We'll then go ahead and begin reading from the file. Now in the example here, we're simply reading into each integer object one by one from the file. We're not doing any sort of stream state checking outside of simply seeing whether or not the read succeeded. If it did, we'll hop into the body of the while loop. If it failed, we'll hop out. But anyhow, there's no bound checking on arrays, so we could technically go beyond the array's bound. And what we'll see right here is we need some way to check whether or not the size is at the capacity. But just for the example here, we're not doing that, but we need to. But anyhow, we can just see here, okay, data array at size, so it starts out at 0. We add to the 0th position, increment size by 1. On the next read, we add to the first position, increment size by 1 to communicate we have 2 objects within our array residing at indexes 0 and 1. So let's go ahead and add that check. So the only update we've done here is that on a successful read, we're going to check to see whether or not the data size is equal to the capacity. So in the case that, how this might start out, let's say we're reading from the file, and this is the initial array, values undefined. Size is 0, capacity is 2. So let's say we read in one value, it's 1, size becomes 1, capacity is 2. Let's say we read in another value. integer value 4. At this point, size is equal to 2, capacity is equal to 2. If we read another integer, note that we're going to get into the condition of if data size is equal to data capacity. In this case, 2 is equal to 2. There are no available slots to add that integer value that we've read. So we'd like to go ahead and resize that array. So let's go ahead and look at, I wrote a function to do this. Let's go ahead and look into the actual resizing process now. So here's resize my array. And I'm going to go ahead and say that this resize operation is simply going to take the previous capacity and multiply it by 2 for the new capacity. So we can see here my array object is taken by reference. So we're actually modifying the my array object that lives in the caller. And we're going to go ahead and record the updated capacity as data's capacity multiplied by 2. Now here's where the fun begins. We need a new array of that capacity. So we'll go ahead and request from the free store manager an array of, and let's say 4. And because it's on the free store, guess what? We need to store the address of that array somewhere. So let's go ahead and look at, say, my data. So here's how it kind of looks right now. We have array, which is a pointer to this thing that's storing 4 and 1. Assume that's on the free store. Size is 2. Capacity is 2. Okay. So after we've got this new array, what we're going to do is we're going to copy over the previous data into the corresponding field to the same index in the new array. So that's what this for statement is doing here. It's essentially going for the data size, so the number of elements within it. Temp of I is going to equal data of I. So 0, 1, and now we have the case where 2 is not less than 2, so we've copied over the old data. We're then going to delete the old array. So data's array. At this point, we have a dangling pointer because the previous array is still pointing to that object for which the memory has been deallocated. So we'll go ahead and take data's array pointer and instead point it to temp. So now at this point, the data object, the myArray data object, is no longer associated with that old array, and the old array's memory has been deallocated. And now its array pointer points to the new resized array, which is 2 times the capacity of the old. So that's what we've done there. And then finally, what we're going to have to do is update the capacity field of the myArray data object to reflect this new size. So we go ahead and say data's.capacity is now equal to 4. And at this point, we can see we have effectively resized the myArray data object's array. So let's just kind of recap the steps necessary to resize a dynamically allocated array. Step 1 is going to be to determine the capacity of the new array. And this could be some multiple of the previous array, and it would be kind of dependent on the context of your application. Thereafter, we're going to create a new array, so a new array on the free store with that capacity, and we'll store its address somewhere. Likely that's going to be a pointer within the function where we're performing this operation. We then have to copy the contents of the old array into the corresponding locations in the new array. So that was where we essentially went through each element of the old array, picking it up, placing a copy of it at the corresponding field in the new array. Okay, at this point, we have a new array. It is essentially the old array resized to some new capacity. And we don't need the old one anymore. We've copied over the old data, so we can go ahead and delete the old array. So tell the free store manager, hey, I don't need this dynamically allocated array anymore. Feel free to reclaim its memory for use in some other way. And then we update the pointer of the array with the address to the new array. That's what we did here when we said data's dot array is now equal to temp. It's simply now pointing to or now storing the address, the base address of the newly dynamically allocated array. And finally, we're going to go ahead and update the variable storing our array's capacity to reflect the new capacity. We went ahead and did that there with data.capacity equals updated capacity. And at this point, you've effectively resized a dynamically allocated array.